Guys, today we're gonna be doing turn 2 week 2 physics quiz. So let's get started with question 1. The motion in which an object has a constant speed in one direction. So we have two types of uniform motion. One in which the object, it has a constant speed, moves in a straight line in one direction. This is known as uniform rectilinear motion. There is nothing to explain about it, you just need to know it. And the other type is when the object is moving in one direction in a straight line. It accelerates it has a constant acceleration, so its velocity, it changes with equal amounts in the same time intervals. So here they said the object has a constant speed in one direction, so we were going to choose uniform rectilinear motion. Next question. The motion in which the velocity of an object increases by equal amounts, so this constant acceleration, so we're gonna pick uniformly accelerated. Again, you just need to know these stuff. Question 3. These are one of the cases. This is case 4 if I'm not wrong. I'm gonna send them on the group once I'm done. So in this case also, you just need to know, this is case 4, when it's placed at 2f, okay, double the focal length, it's going to be inverted and the same size. Okay, I'm going to show you real quick why this is so. Sorry, hold on. Here, so how do we get the image? We draw, okay, hold on, let me just, yes, we draw a parallel line to the principal axis, which is the x-axis, and then it passes through the point F, or the principal focus, and we draw another line passing through the optical center or the origin. We will see that they intersect at 2f and they are the same size, and it's inverted. One is going up and one is going down. So this is how it works. I will send the cases after I'm done. This is how you solve this question. Just memorization, you just need to know this. Question 4. Here, this is an application on Newton's third law. This will obviously 100% come tomorrow in tomorrow's exam. We just need to know is for every action, there is an equal and opposite reaction. So if I exert a force on the door, there is another reaction in which it will be the same magnitude and opposite. So me on door, the reaction is going to be door on me. Same magnitude, but opposite direction. Question 5. Here we are supposed to, we have examples, and we are told to know whether these are action and reaction pairs or not. So first one, we have action. The wings of a bird pushes the air downwards. So we expect the reaction from bird to air, air on bird, which is correct. Reaction, air pushes the bird upwards. Notice here how they said downwards, but we have opposite direction, so it's going to be upwards. This is correct. Action, a swimmer's hand pushes the water backwards, so we expect it's going to be from water to swimmer. As we said, swimmer to water, it's going to be water to swimmer. So the water pushes her hand forward, backwards, forward, they're opposite, so it's correct. Action, a hammer strikes a nail downwards. We expect the reaction to be nail on hammer, upwards. But here they said the nail hits a wooden box downwards. We cannot have three objects, okay, the hammer, nail, and the wooden box in an action-reaction pair. So this is wrong. It's supposed to be nail on hammer. Since the action is hammer on nail, reaction will be nail on hammer. So this is wrong. Action, a player shoots a football to the right. We expect the reaction from football to player to the left. Here they said to the left, which is correct. But here they said football pushes the air, which is wrong. It's supposed to be football on player. Next question. Okay, I will put this on the whiteboard. What is the average velocity of the particle in the time interval 0, 3? So just for you to know and understand, I'll draw a line from 3. This is 3 seconds. 3, 3 seconds. So the average velocity, okay, it's equal to the secant, which joins the time interval 0, so point 0 here and point 3 here, those 3 seconds. It's equal to the secant that joins those two. It's equal to the slope of that secant. So we calculate the slope, rise over run, y2 minus y1 over x2 over x1. We have y2 here, it's 2, and y1 is 0, so 2 minus 0 over x2, which is 3 minus 0, x1, 3 minus 0, 2 over 3, which is 0.667. We round it, it's going to be 0.67, which is your answer. Moving on, question 7. Okay, which of the following are possible outcomes of a zero net force acting on an object? What do they mean here by zero net force? Zero net force is like, imagine you have an object when you have no forces acting on them, when you have no friction, no weight, no external force, it's just there. We have two cases in that scenario. It's either it just stays there and remains at rest, or it was moving and there was no forces acting on it, so it will just keep on moving with the constant speed or velocity. Here on the options, the object remains at rest, it's correct. The object decelerates. No, the object cannot decelerate with zero net force. There is no force that's allowing it to decelerate. There is no friction, so it's wrong. The object moves along a straight line. Yes, I forgot to mention it moves along a straight line with a constant speed. Velocity is also the same, it's correct. The object moves in a circle. No, that's wrong. It actually moves in a straight line. Next question. Okay, here I'm gonna do this on the whiteboard to remind you, since I know some people forgot. Imagine you have a converging lens here. Okay, and we know here's F as well. So here they say the point on the principal axis, which is this axis, I say it as x-axis so you don't get confused, it's known as the principal axis, through which the rays parallel to it, so let's take a ray parallel to it, refract through the lens, passing through a point or appear to come out of it, passing through this point. If you remember, we used to use this ray to find the image of an object in the cases. So this point through which it passes through is known as F, or the principal focus. Again, you should just know this. And the distance between the optical center is just like O, it's the origin. So the distance between the principal focus F and O is known as the focal length. That's all you need to know. Next question. Okay, this is also an application on the cases. Where should we place an object to produce a real image? So this is also memorization. Cases 2 to 6. Okay, these are the cases in which we produce a real image. It is any object that's placed beyond F, like this part. Any object placed here will produce a virtual image. Just know this. Any object like between the focal length, between F and the lens, or F and the optical center, it will always produce a virtual image. Anything beyond that will produce a real image. So where should we place an object to produce a real image? Anything beyond the distance, beyond F, sorry. And where should we place the object to produce a virtual image? Between F and the optical center. This part. That's all. Next question. Which of the following statements describe a ray describing the ray diagram is true? So here we find the image formed here is virtual. How? Because it is dotted, okay, and it is upright. It's not inverted or anything. It's not down. It's upright. So let's start. This is also known as case 1. Okay, it's known as the magnifying glass. Let's start. The lens is used here as magnifying glass. Yes, that's true. since the object is magnified. The image formed is virtual and upright. Yes, it is virtual. It's dotted and it's upright. Yes, it is. The image can only be seen through by IQ. Yes, this is correct. To give you an example, imagine you have a magnifying glass. You see that this object. So you can see this real image. Okay, you can see this real image, but the only person that will be able to see the virtual image here will be someone that's looking from behind. So this is how it works. Like, if you're here, you're looking at this object through the magnifying glass, it will appear magnified, but the virtual image formed, you cannot see it. Your eyes cannot go like this. The other person from the other side will be able to see it like this. This is basically it. So the image, yes, it can only be seen as by IQ. Your eye cannot like see stuff like this. No, doesn't work. The image can only be seen by IP. No, that's not wrong. That's wrong, sorry. The image formed is between the focal length and the lens. No, that is in case 1. Our image is not formed between the focal length and the lens. So it's not formed, like if we take this as the f, the principal focus, and this is the focal length. No, the image is beyond the focal length. That's all. Next question: what is the speed of the object at point A? So the speed of an object, like we have here a curve, we do not have a straight line. So the speed of an object at any point on that curve is equal to the slope of the tangent. Here we have the points, so we basically use 0 minus y2 minus y1, 0 y2 minus y1, 5, over x2, 4 minus x1, x2 minus x1, 4 minus 10, negative 5 over negative 6. Plug that in your calculator. You'll have 5 over 6. You will get 0.833, which is the correct answer. Next question. The instantaneous acceleration at the particle at time 4. Okay, so again, I'm just going to remind you, acceleration is velocity over time. And since we have a curve here, the acceleration at any given time, here it's 4, is equal to the slope of the tangent. They drew it for us, and they also told us the tangent to the curve intersects the points 4, 1 and 4.80. We do the same thing. Slope y2 minus y1, y2 minus y1, 0 minus 1, over x2 minus x1, 4.8 minus 4. Plug that in your calculator. 0 minus 1, 4.8 minus 4. I'll get negative 5 over 4, which is the same as negative 1.25. Next question. I'll remind you, a free body diagram is basically a diagram in which the object, okay, is represented by a dot, and all we have to do is just draw all the forces acting on that object. So here we have a box resting on an inclined plane. So this is your inclined plane, this is your box. Weight will obviously be downwards. Okay, this is weight. A normal will be perpendicular to the surface, so like this. This is normal. And you have an external force, F, let's say, pushing on that inclined plane. So this is the one with the most logic. This one, yani, it's makes more sense with the description. So this one's the correct answer. The second one is a lamp hanging from the ceiling. So this is the ceiling. We have a lamp hanging. Okay, we have tension force right here, since it's between a cord, a lamp hanging from a ceiling. You have tension, and you're gonna have weight as well, pushing downwards, which is here. Last description: a ball kicked at an angle by a child. So this is the ball, the dot. It's kicked by an angle, this angle, with a force P. Okay, and the weight of the ball is obviously downward. So this is the correct answer. Which of the following are possible outcomes of constant unbalanced forces? Okay, I'll remind you again. A constant balanced force is basically when the net force is zero. And I said before that we have two cases. The object will remain at rest, or it will continue with constant speed or velocity. Here, it's the opposite. Constant unbalanced force. That means imagine if you have an object and you're repeatedly pushing it with the same unbalanced force. So the object will obviously not remain at rest. Okay. You have an unbalanced force. It may decelerate at a constant rate, since imagine you have friction. That friction is slowing it down. It's unbalanced. Okay, slowing it down with the same rate, since they said here constant. Or it can be an external force that can accelerate it with a constant acceleration, constant unbalanced force. You repeatedly put that force, so it will accelerate with the constant acceleration. The object moves with a constant velocity. No, you have an unbalanced force. It will obviously accelerate with the same constant acceleration, as they said it's constant. The object accelerates at an increasing rate. No, the acceleration is constant. Why? Because they said here constant unbalanced force. If they said unbalanced force, then yes, the object accelerates at an increasing rate. But here they said the constant unbalanced force. So it's wrong. Next question. Here you shouldn't be fooled or distracted by all this. Okay, imagine if it's not here. All that concerns me here is the box moves with constant speed. If the box moves with constant speed, that means that acceleration is obviously equal to 0. Okay, the box is said to be in equilibrium. This is memorization. Since the acceleration is 0, there's no forces, so it's just at equilibrium. It's just there. This behavior is known as inertia. Okay, يعني the tendency of an object to resist changes in motion. Okay, this is known as inertia. Also, you just need to know this. There's nothing to explain here. Question 16. Okay, let's imagine we have a ball, okay, that's falling in the air with weight 3. Okay, at the same moment it experiences drag. Drag is the same thing as air resistance of 1 Newton. Okay, so here they want the force exerted by the ball on Earth. We can use here Newton's third law. We know that Earth exerts a weight of 3 Newton on the ball. Okay, here they said the ball on Earth, so it will be the same magnitude but opposite direction. So if Earth pulls on the ball by 3 Newton, then the ball will exert a force on Earth also equal in magnitude 3 Newtons, but in the opposite direction. Since weight is downward, it will be directed upward. Drag, air resistance, okay, pushes the ball upward by 1 Newton. So the ball on air, so I'll repeat, air pushes the ball upward, okay, by 1 Newton. So the ball will exert a force on the air 1 Newton, just not upward, opposite to upward, downward. This is how you solve the question. Moving on, question 17. Here the keyword here is it's immersed into water and held at rest by a cord. When we see those two keywords, we know that there's obviously tension since it's a cord. So tension here is shown. And immersed into water. Any object that's immersed into water will have upthrust. It will allow that object to have a tendency to move upward. This is called upthrust. So we will add upthrust here, upward, tendency to move upward. And of course any object on Earth will have its own weight, so we'll add that, and it's downward. Question 18. We have here two horizontal forces, okay, acting on the same block along on a frictionless floor, so there is no friction. Friction is negligible. Two, we can exert a new third horizontal force F3 that also acts on the block. Okay, so Here, choose the correct magnitude and direction of the new force that we're gonna add to complete the table below. Here, the block is stationary. We want to add a new horizontal force F3 to make the block stationary. Remember, when we have an object that's in rest, that means we have balanced forces. And we have balanced forces, that means the net force is 0. So how do we make those net forces 0? We want them to cancel out, right? How do we make them cancel out? That 3 needs to become a 5. So we add another 2 plus 2 to the left side, which is what we're doing here. The block moves with a constant speed. If you remember, I said a constant speed is in the same case as stationary. We want to have balanced forces, which is net forces. Net force is 0. Okay, so we'll do the same thing. We'll add 2 newtons to the left. They will both cancel out since 5 and 5, and they're both acting on the same object. Okay, so they're both acting on the same object. They will cancel out, and that's it, to the left, to support the 3, make it 5. In the last case, it's a bit tricky. The block moves to the right with a net force of 8 newtons. So the final force will be 8 newtons to the right. We want to add a force here, okay, that will make it equal to 8. So I'll write this in an equation. The final force, 8, is equal to 5 plus F3, okay, minus 3. Since 3 is in the opposite direction, minus 3. If we add 3 on both sides, 11 is equal to 5 plus F3. Okay, so F3 is equal to 11 minus 5, which is 6. 6 newtons to the right. Why to the right? It's because here they want us to move the block to the right with a net force of 8 newtons. So the net force, I'll repeat, is the total force. So I put it here, okay. So we want it to move to the right, so we need to add a force F3 here. Okay, so 5 plus F3 minus, we don't forget the 3 newtons to the left, minus 3. Then we just solve. We'll get F3 is equal to 6. That's all. Moving on to the last few questions. Question 19. In which situation is it possible that the block is stationary? So here we have no friction, so friction is negligible. When is the block stationary? When the net force is equal to 0. When is the net force equal to 0? When they both cancel out. Here we have F1 and F2, horizontal, acting on the same object. If they're not acting on the same object, then it does not work. They have to be opposite and acting on the same object. Here they're not opposite, so it's wrong. Also here as well, not opposite. Here as well. This is the only one that is opposite, same magnitude, opposite direction, and acts on the same object, so it is B. Question 20. Again, the time at which the forces acting on the object are balanced. What do we mean by balanced? F net is 0. Here we have acceleration time. The trick of this question is to know that when you have balanced, as I said, when you have balanced forces, then you have constant speed. What I mean by constant speed is that there is no acceleration. So acceleration must be 0. So at what time is acceleration 0? It's 2, which is the correct answer. Next question, 21. What is the magnitude of the force acting on A? It's simple, 5 newtons. Why don't these forces cancel out each other? As I said previously, they act on different bodies. How do they cancel? If they act on the same body and opposite and equal magnitudes, opposite direction and equal magnitudes. What is the symbol representation of the force exerted by A on B? So how do you write this, just in case you don't get confused? A on B, so A is first, so F A on B, A is first, and then you write B. So you take the first, put it first, and B second, you put it second. So F A on B, AB, F A B. Next question. This is Newton's third law of motion, also memorization. Whenever a body A exerts a force F on body B will exert a force on A, equal in magnitude and in the opposite direction. You just need to know, memorize this. Okay, this question is a bit challenging. I'll explain it. Sorry. Okay. So we have here box B, right here, that is dragged by a rough horizontal surface S by a force F. Okay, so what are the forces on the box? It's F. What is the, we have a horizontal component of F and we have a vertical component of F, which is this. Okay, sorry, this is your horizontal component. This is the forces acting on the box B. Here they say select the arrow that represents the net force exerted by the surface on the box, not the force on the box, the surface on the box. Okay, so what are the forces exerted by the surface on the box? We know that there is obviously normal, and we have friction. These are the forces exerted by the surface on the block. These are the forces. They want here the net force. So what do? We calculate the resultant. It's going to be, by Pythagorean theorem, it's going to be like this, which is this. And here we finished the quiz. I hope this helped, and I wish you the best for tomorrow.